Hello students, welcome to Eduauraa. I am Swati Moona, your chemistry mentor, and we are here to discuss past year question. The chapter today is coordination compounds. Let's see the first question. This question, students, was asked in Advanced 2020. And the question is, choose the correct statements among the following. Option A, FeCl4- has tetrahedral geometry. Option B, cobalt, En, NH3 twice, Cl2 plus has two geometrical isomers. Option C, the complex FeCl4- has higher spin magnetic moment than the complex of cobalt, En, NH3 twice, Cl2 plus. And option D, the cobalt ion in the complex cobalt, En, NH3 twice, Cl2 plus has sp3d2 hybridization. Now students, in order for us to get the correct answers, let's solve these complexes. The first complex, which is FeCl4- has Fe in +3 oxidation state. So the configuration of Fe in +3 oxidation state will be Fe in +3 will be argon, 3d5 and 4s0. Now as you can see, 3d5 means 5 unpaired electrons in the 3d orbital. Also, the ligand here is the chloride ion. The chloride ion does not cause pairing of electrons. So the d5 electrons remain unpaired. As a result, the geometry here will be tetrahedral since the hybridization will be sp3. That is, the 4s orbital and the 4p orbitals combine together to give you sp3 hybridized orbitals. So students, our first correct option is option A. Students, now let's look at the option B has a complex of cobalt with the ligands En. En is ethylene diamine, and students, it is a bidentate ligand. The next ligand is ammonia, that is 2 ammonias, and here 2 chloride ions. Cobalt having this complex shows octahedral geometry. Now, arranging the ligands, we get the first structure, which is having ammonia in the trans position. The second structure will be having ammonia in the cis position. And the third structure will be having chlorine in the trans structure. So students, we will have 3 geometrical isomers here rather than the 2 which has been given in the question. So now, moving on to option C. Option C has the first complex, which is FeCl4-. FeCl4- has Fe in +3 oxidation state. And we already know that Fe in +3 has D5 configuration. D5 configuration such that all the electrons being unpaired shows 5 unpaired electrons. And the magnetic moment for this particular configuration will be root of n plus 2 Bm, where n is the number of unpaired electrons. So here, the number of unpaired electrons being 5, you substitute n with 5. And the answer will be 5.92 Bm. The second complex, which is the cobalt complex, has cobalt in +3 oxidation state. In +3 oxidation state, cobalt shows a configuration of argon, 3d6 and 4s0. Also, the complex has 2 strong field ligands, that is En and ammonia. Because of these strong field ligands, the 3d6 electrons get paired. As a result, no unpaired electron is left. So, the magnetic moment for this particular complex will be 0. So, students, the option C, that is FeCl4 minus, has a higher spin-only magnetic moment than the cobalt complex. Looking at the option D, it is a cobalt complex. Here, cobalt is in +3 oxidation state. In +3 oxidation state, with the strong field ligands, the two 3d orbitals also take part in hybridization. So, the hybridization here is D2sp3 rather than the sp3d2 given in the question. So, finally, students, we can conclude that the correct options are option A and option C. Students, the next question is total number of cis, nitrogen, manganese, chlorine bond angles, that is manganese nitrogen and manganese chlorine bonds in cis position present in a molecule of cis Mn En twice Cl2 complex is. Here En is ethylene diamine. Students, this question was asked in Advanced 2019. So students, in order to find our answer, that is the Mn nitrogen and the Mn chlorine angles in the cis position, we need to draw the structure. The structure looks like this. Mn in the center with 2 ENs and 2 chloride ions. According to this structure, we can see that there are 6 Mn nitrogen and Mn chlorine angles in the cis position. So students, the answer here is 6. Moving on to the next question. This question, students, was asked in Advanced 2018. The question reads as, the correct options regarding the complex. The complex is CO, En, NH3 twice, H2O, the whole 3 plus, where En is ethylene diamine. Option A, it has 2 geometrical isomers. Option B, it will have 3 geometrical isomers if bidentate En is replaced by 2 cyanide ligands. Option C, it is paramagnetic. And option D, it absorbs light at a longer wavelength as compared to the complex cobalt, En, NH3 4 times the whole 3 plus. Now students, in order for us to solve this question, let's see the options one by one. Option A. Option A says that it has 2 geometrical isomers. So for that, let's start with the structures. The structure being 1 and the structure being 2. So here we can see that it actually has 2 geometrical isomers. Option B says that it will have 3 geometrical isomers if the bidentate En is replaced by 2 cyanide ligands. So let's replace the bidentate En with the cyanide and let's work out the structures. Structure 1, structure 2 and structure 3. So thus we can see that it has 3 geometrical isomers. Moving on to the next option. It says that it is paramagnetic. Now students, in order for a complex to be paramagnetic, it should have unpaired electrons. But since here, En and ammonia are strong field ligands, they cause pairing of electrons. And hence, the complex will be diamagnetic rather than paramagnetic. So this here, option C, is an incorrect statement. Moving on to the next option, that is option D. Option D says that it absorbs light of a longer wavelength as compared to the complex which has 1 En, that is ethylene diamine, and 4 ammonia ligands. Students, En and ammonia are strong field ligands. Here, the difference of energy between the Eg and the T2G orbitals is quite high. But that is not the case for the complex with water as a ligand. As a result, the complex with water being a weak field ligand, the complex with water absorbs the light of a longer wavelength, thus making the statement D to be the correct statement. So students, our correct statements are option A, option B, and option D. Hope you have enjoyed the session. This is me, Swati Moona, signing off. Keep learning, keep practicing, and thanks for watching Eduauraa.